Hello, world, and welcome to Code or Not to Code. I'm Merely Eva, and as always, I'm super happy to be here today. And as always, I'm here with Stefan. How are you doing?
It is, well, I'm sad happy, or is it happy sad? It's the final
Yeah,
episode of the year, but
it
not
is.
the
And
final
that's
episode
also
altogether.
not the final episode altogether, but that's why we're wearing our silly hats. We do that every year for our final episode. And it's a really special episode today because we are part of C# Advent. We are today's Advent calendar, and that's super exciting for me. It's a really, really fun event. Thank you already so much for the organizers. It's really nice to be part of it, especially I think because our very first project all of those years
Oh, yeah.
ago was an advent calendar, and so this always brings so much joy to my heart. And yeah, so if you want to check out any of the many sessions, there's so many different topics. I don't think there's anybody who cannot find something for them in this advent calendar. And yeah, and we're super excited to be today's how would I say contribution. So if you're actually new to this show, if you see us for the first time, Stefan and I meet every other week and code together and learn something about .NET and C#. And yeah, we've got many different projects. And it's one of those things where whether you're like quite early in your C# .NET journey like me, or whether you're a seasoned developer, I think everybody can tune in and learn something, or that's at least our goal, is to learn something. Stefan needs to learn something each episode. I need to learn something each episode, and we also need to have loads of fun along the way. So that's our goal, and we hope that, yeah. Hi, Eric. Thank you so much for joining. We hope that you also have a good time with us tonight. Right. I think without much further ado, we might.
Yeah.
We might.
Jason knows it.
He knows us too well. Yeah, I think we've been generating quite a bit this year, haven't we? Yeah, but what are we generating today? What do we do today?
Well, let's build up to it. I have here a little application, and let's start. I want to write two strings.
Yep.
A string called, not called, but has this content hello world. And text 2, which is C# Advent. Oh, it's actually C#, right? Advent calendar. I always write it wrong. Let's do my.
Let's cheat.
I just copy paste.
Yes.
Calendar. Yeah, I always saw. Okay, cool. Oh, next end. And now I would like to get the combined length of both strings. And well, we have a type called our type. Now it would be cool if we'd had a method, our method, that I just need to pass in those two references to those two strings, and then it would be giving me the combined length. Could you help me out there?
Of course I can. No worries at all. I'm just gonna jump into our type. Well, okay. Yes, I'm here. Woohoo! So yes, I'm actually we're using Code with Me, so I can actually code with Stefan live. Hopefully. Let's see. So I'm gonna write a public static, int returning method, our method. And I'm gonna grab your strings, and you can always see sort of the experience levels of developers by the by the speed that they can type code, especially when they're sharing their screen. So mine's a bit slower, but it's okay. We can deal with it. I'm always so surprised how fast you type, especially in these situations. So well done. I'll get there.
You'll get there. Yeah.
And what do I want to do? I just want to return the length of text 1 plus the length of text 2. So I think that should solve your problem.
It seems to compile. Let's give it a try, and we should get 30, 35-ish. Oh, 36.
Pretty close.
So we have the combined length of 36 characters. Cool. What if I get Well, string is a class. So that's a reference type. That means we can actually pass null to it. Well,
Yes.
we do have nullable reference types enabled. Our project says nullable enable. So I get a warning here that I'm converting a null literal to a non-nullable type because I didn't mark this as potentially null. Well, I could. Now I do get the warning here because, yeah, I see that you marked the string. You didn't mark it as nullable.
Nope.
So the design expects to get a non-nullable string, so at least a zero-length string. I just ignore this warning here. Let's use the null forgiving operator. And let's see what's going to happen now. Oh, yeah, we of course run into the billion-dollar mistake, the null reference exception. And it happens exactly here when I try to dereference the length of this null instance because I passed in, well, here I passed a non-null string, but here I passed the actual null string, yeah.
Yeah. I mean, I can already also see some warnings on my end, actually, that I ignored.
Ooh.
What are those?
That's CA 1062. I'm not sure if you actually get this by default. What we did in our project is we enabled all of the analyzers that, well, actually all of the diagnostics that come along with the .NET SDK. I think all actually doesn't mean really everything. I think there is a handful of analyzers that you explicitly need to opt in. Or they have been marked as deprecated and therefore are no longer included in the all thing. But it's not truly all, but it's all that kind of almost all.
It's a lot.
And
yeah.
one of these, CA 1062, says, okay, we should validate arguments of public methods. We have a public method, and if it's since a user could pass in null, and we now run into the null reference exception, and you don't seem to handle null because, well, what would be the length of a string that's null? Well, we could return 0, but what's then the difference to a string with a 0 length? We could return -1, but then we would return, the first string has a length of 7, and then we return a length of 6. Yeah, it kind of doesn't make sense. So our string length combining method doesn't really make sense to handle null. So we should validate our arguments via the argument null exception.
All right. Well, let's do that. I'm just going to be, oh no, my formatting. So I'm just going to be really naive here. I'm just going to be like, so if text1 is null, then yes, formatting. Oh no, what happened? Did you see that? No.
Yeah. It seems that formatting isn't. Maybe the format already has Christmas holidays.
Oh, I actually, so I gave something away here already.
And auto-completion is too eager.
Yeah, but I can, exactly, I can have like a little, I can have text1 here. So maybe, okay, I think now it's not very happy about my validation here. Well, it actually, I can already sort of give it away a little bit because it already tried to do name off here, but I like to do that as well, actually. Because if I now copy paste this and I want to have text2 is null, throw new argument, null exception, it's actually happened to me in the past that I just forgot to to also edit this, or that I had like a typo in it, because I mean now everything's actually getting warnings, but I think that's because of the fancy thing that you have. Yeah, because like when I'm working, it's happened to me that I have a typo in there, and then this sort of error message doesn't make any sense. So what I like to do is to have this name of text1 here, and let's have name of text2 there. And what this does really is it just avoids typos, because now this doesn't even compile.
Oops, excuse me.
And I cannot use name of anything that doesn't exist in this context. So even like a variable that's technically exists but not in this context, I also can't use it. So it just really gets rid of those. It helps me as a developer. Let's put it this way. And I'm just gonna build. Oh, great, that works as well. But could you look quickly under the hood? Because what's really interesting is if you go to the lowered C#, you can actually see what the compiler makes of it. And that's exactly what I had actually before. So it just creates like it sort of this is actually
name
a little bit
name of really it's a constant string, so the compiler will just convert this to a string. But it's not. Yeah, it's a cool thing is as you mentioned, it's refactoring safe. So if we were to do a rename on that and I rename it now to text free, now all of the references are updated automatically. So that's really cool.
Yeah. Right.
Let me give that a run.
Yeah, let's run it for a second.
We no longer get the null reference exception. We now get the argument null exception, and when we ever have an argument null exception or any exception that is derived from system.argument exception, it really indicates that the developer made a mistake. So I held the API wrong. In this case, I passed null to something that doesn't accept null and doesn't handle null, and it tells me exactly which parameter I evaluated. Violated. There we go.
Violated. Yes.
Well, text 3. Let's do text 2, and I know okay, the parameter text 2. I mean, we could be more explicit and actually use named arguments and say, okay, text 1, text 2. Okay, now that's slightly confusing. Maybe I call this string 1 and string 2 so that we see as for the parameter text 1, we pass in the argument string 1, and for the parameter text 2, we pass in the argument string 2. But we suppress something null here, and we now indeed get the null validated, and I see developer, in this case me, made a mistake.
That's a good start, and it works as expected. But it's how many? It's like 8 lines of code. So what I see a lot of people do is just get rid of these curly braces and have it like this, or even like you can have. Oops, that was a bit much. You can just have it all in one line. It doesn't want to do it.
It doesn't know.
Okay.
Yeah. Well, I don't want to do it either.
in one line. But actually, we don't have to worry about it at all, because there are also some guidelines or some suggestions. If you hover it, you should have it as well. Yeah.
CA 1510, that's a newer one, says use the argument null exception throw helper. So to replace the common pattern of if something is null, and if it is, then throw an argument exception that was checked for null as a name of, with just a single method call.
Amazing. Let's do that. Can I refactor it easily?
Should be refactoring for it, yeah, or a code fixer. Yeah,
easy. I'm just gonna do like this. And now this looks beautiful. It's easy to read. It doesn't take up much space. And if you run it, you'll probably see it still works as expected.
It should be exactly the same. Nothing should have changed from a behavioral perspective. Yeah, we still get the argument null exception that text 2 is still very null.
Yeah. And under the hood?
Oh. Yeah, the cool thing about this is Swift null actually takes not 1, but 2 arguments. Where was this introduced? .NET 5, 6, something like that. I always forget. Where this is actually a default parameter. So if we don't set it, it's okay. But it won't be null if we don't set it. The compiler, due to this attribute, the compiler will replace it and will actually use whatever we passed in on the left-hand side. well, we passed in text1. So if we decompile this now, what actually happening? Yeah, we pass in text1 to this method, and the second argument, it will be the string text1 that will be used for the argument name.
Nice.
What's actually interesting about that is, what if we had a local function? I'll just make like an identity function that you pass something in and you get it out again. Let's call it func. And let's pass in a string and let's just return it. So that's all it does. If we were to pass now func text1 to it, what will happen now, due to this caller argument expression, it will use, well, exactly what we passed in. So this func opening brace, opening parentheses, text1 closing parentheses will be used as a string for this method. And well, actually, yes, there it is.
Oh,
it's actually func text1, because this is what we wrote here.
Yeah.
That's the thing about the caller argument expression. It will use the expression that you called this method, or that you passed for this parameter with. And we said, well, func text1. So func text1 it is.
Okay. All right, but yeah, we don't have a func, so for us this is
it for argument null exceptions, or for any argument exception that really just takes the name, or this really should be the parameter name, because then of the resulting argument null exception, it will be the property, where can we find it? It will be then passed to the base, which is an argument exception, and every argument exception has a property called parameter name. Parameter name, can we find it? Oh yeah, there it is. So if you inspect the exception at runtime, you see that the parameter name is the parameter name that it passed. So it should be the name of the parameter and not something else.
Yeah, makes sense. All right, but now actually our method is pretty cool. It's kind of ready to go. I mean, okay, it let's be real here. It's just, it adds to the lengths of two strings together. It's like not super exciting, but let's just imagine that this has never been done before. And it probably hasn't. Or like that this is like a really, really super cool method that we want to reuse many times.
So let's build a library.
Yes.
Let's build a new class library. Let's call it library. And create. And yeah, let's move the type over to. Can you do that on your end? Does this actually work?
Let me see. Oops. Oh my goodness. Yep. So I can.
So I was wondering if you can actually drag and drop it.
Oh, drag and drop it.
There. Does this work?
Let's see. Oh, wait. No.
Does not.
But maybe I can. Yes. Is it there?
Ah, cool. Yeah, it is.
Cool.
So let's delete the old one, and now in the library,
have unlimited power.
We now have. I will just briefly fix the namespace. So the namespace has the same name as the the base namespace has the same name as the DLL, or the library that it is contained in. So we should now be able to be using it, and it's no longer the project, and the project doesn't reference this very new library. So let's reference this very new library. So we are now referencing our brand new library. And yeah, now we can use this method from a different library, and it still works all the same.
Amazing. But okay, if you have like a library, because you mentioned that this throw helper was actually only available from like a certain .NET version, right? And if we have a library, we want to make sure that it is reliable.
So then this argument null exception, I think argument null exception existed forever, I think. But the well, forever.net. But this throw if null method, a static method, this throw helper was added just, well, rather recently, was added in .NET 6.
Okay.
And well, our library is so cool. I mean, currently we only target .NET 10. What if we want to multi-target it? So, because this can't be consumed from a .NET framework application. And like a very good compatibility thing, if you still want to do the Windows-only .NET framework, is .NET Standard. So if we target .NET Standard 2.0, we essentially now emit our library twice. Once it's targeting .NET 10, once it's targeting .NET Standard 2.0. And I mean, .NET 8 is also still supported, so maybe let's also target .NET 8.
Okay.
And just to get some multi-targetings going on. And if we build it now, we see problems is arising. Because, well, .NET 10 and .NET 8 all is good, but if we switch to .NET Standard 2.0, get compiler errors, because in .NET Standard 2.0, this method just didn't exist yet.
Okay. Well,
so
what do we do? My first instinct is extension methods.
Ooh, yeah.
I've built my very first extension method on this stream many months ago. So I'm going to add a new class. I'm going to call it argument. I'm going to have a typo. I'm going to believe in myself. Exception extensions. Whew.
If you do too many typos, then you're definitely spending too much time with me.
Really? I can't
I do
remember.
typos all the time.
Oh, okay, but you're so fast that by the time you like fixed it, by the time I finished reading it, so that's yeah. And okay,
before we go ahead,
yeah,
because we're currently targeting .NET Standard, or when we target .NET Standard 2.0, the default language version is C# 7.3. However, we are building with the .NET 10 SDK, so we could increase the compiler. We could use this C# 14 compiler with our .NET Standard 2.0 project. Not every language feature will work, but most of them do. For example, we currently can't use file scope namespaces, because C# 7.3 didn't have file scope namespaces. So let's jump into our library and let's bump the lang version to C# 14. And now we should be able to use if it, waiting for context. Okay, let's do it manually, because what I would like to use is file scope namespaces, so we can, we need less horizontal space.
Yeah, that'd be nice. Amazing. And well, I'm also gonna go cheating. I think I'm just gonna grab the BCL code if I can. How can I also change?
Oh yeah, you need. Can you F12 into it to see the?
So. Yeah, I think so. Let's see. And I'm gonna paste this. So that's the throw, and okay, perfect. So that's literally just whatever we had before when we have 12 inted. There's some attributes. I'm just gonna comment them out for now because we're gonna get to those a little bit later. You can, if no, I can do it. I can do it. I'm so fast.
I'll do the does not return.
Okay, perfect. Thank you.
And maybe I do a new line here, so we fit everything on the screen and we see our two arguments. Yeah, cool.
Yes, and this is also
this is essentially the implementation of the base class libraries for if null. So we have the for if null method, then checks if it's null, and if it's not, then calls the throw method. Well, which throws an argument null exception. I'm just gonna change a bit the accessibility.
Exactly.
Just making this private and making all of this internal, since we now have a library.
Okay,
and we don't want to expose this throw helper. This shouldn't be really part of the functionality of our library. Well, we could build a library that exposes various throw helpers, but our library exposes the string length counter. So let's hide this implementation. Let's make that internal.
Yeah, for sure. And also, because it's an extension method, we need a receiver. And that is the argument exception, right? Oops. That wasn't a typo. Okay. Because I still remember this keyword. It took me ages to remember it. But yeah, after a couple of times on the stream, I did remember it eventually. So
if we're gonna switch back, switch back to the user and switch to net standard. Doesn't work. Well, it actually, the error is now different. It says cannot access non-static method through if null in a static context.
Yep.
So
because I think these methods, they're like these. They're like you need like an instance, right? For it, so it would have to be something like this. Oh well, it works actually.
Yeah.
But that's not nice. That's not what we wanted, right?
It's also a bit suboptimal because we are creating here a new instance of an exception.
Yeah.
That we then may throw or not throw. In the case we don't throw it, we now created a new instance that we're not using. So we essentially created garbage for the garbage collector to immediately collect without any value. So because actually this method should be, well, if it's not throwing anything, in the positive case, it should be allocation free. It just takes two references, does some integer-based arithmetic. Nothing is allocated on the heap, everything on the stack. So super fast, no GC involved. But now it is.
No, it is. So we don't like that. Suboptimal is a nice way of putting it.
Technically, what we could do, since it's just a static method, we could just call the static method. Oops. But it is on this extensions type. And then I guess we could pass in null in here because it's not really observed. But now I had to change code in order to make it work. I mean, this would work for net standard 10.0 as well, and we not have anything with allocations, but we actually had to update our code. Can we do it without? Can we do it by just leaving the .NET 10 code as it is idiomatic, but for the lower target frameworks, it still kind of works.
Yeah. But I do remember last episode, we had Stuart with us, and he showed us extension members, I think they were called, which, they came with C#14. And I want to give that a go because I really like that. Because you kind of get rid of this keyword that it took me ages to learn. Now I can unlearn it again. And there's just this extension block, I believe. So you can have the receiver here. And then, oh my goodness. Oh. And then I can just throw all of this in there. And then all the formatting is gone.
Since the IDE isn't doing the formatting.
Sorry. I can't even format.
All good. All good.
It
Looks
is?
good. Yeah.
Oh, okay. It just took a while. Right. And you can also see that.
No, go ahead.
I was just thinking, because this is actually, the exception is actually grayed out. I was just wondering if I can use it. But actually, I can't, because do you get an error?
Yes, cannot use extension parameter exception in this context because it's a static method.
Yeah.
If this was an instance method, instance extension, we could utilize this exception variable or this extension variable in here, but not in a static context, because in a static context, there is no instance. Static.
Nice. So actually we can get rid of, I can't delete it. Why? Okay, the line stays. I can get rid of this. I still need the argument null exception there, the type, because we need we need the type of the receiver kind of.
And now you wrote a true static extension method. And yeah, we just saw, well, on .NET 10 still, we use what's in the box, what is available since .NET 6. But on .NET Standard 2.0, we haven't changed any syntax. It compiles, and it also should work. Well, let's give that a try. Well, the sample that we're having, the executable that is consuming the library, is currently still targeting .NET 10. So it will be using the .NET 10 version of the library. So there is an algorithm to it. It uses the best match. If we were targeting .NET 4.8, this is the Windows-only .NET framework. Actually, our library is not targeting any .NET framework. We are, however, targeting .NET Standard, and .NET Framework 4.8 is compatible with .NET Standard 2.0. So this should work. And nullable value. It, of course, does not. Please use language version. Oh, yeah. The default language version of .NET Framework 4.8 is also C# 7.3, and we don't have nullable reference types enabled, but I enabled them, so yeah, it doesn't work. So let's also bump the language version of our application. Nice. And now we should be just able to run it. It now runs on the Windows-only .NET Framework. And our library still validates, where is it? All the same. Actually, well, there it is. System argument null exception value cannot be null.
Cannot be null.
Well, this kind of missing the parameter name. But yeah, we commented out some attributes. We will just come to that.
Yeah.
Well, maybe actually just now.
Well, actually, maybe before we get to that, because
hold on a minute. We have a question in the chat.
Yes.
What is the tool that allows you to draw on the screen?
That is an excellent question, but be careful, it is addictive.
The thing is called Zoom It, which is available on Windows. You can download it individually. It's also part of the so-called sys internals suite. But now it's also part of the Windows Power Toys. So either individual or with one of those two packages, and then you see a little icon in the taskbar, and then you can draw and text and change colors to orange and so on. But yeah, I can't live without this tool anymore. It's
yeah, you can't. Once you get used to it, it's really difficult to speak without it.
Yeah.
But yeah, no, it's super fun. And you can have different colors, and it's really, really cool. But yeah, what I was going to say before is that now, actually, we just have this code in there all the time, even if we do not need it. It compiles every single time. So I was wondering,
we only need it for the .NET Standard 2.0 target, yeah.
Exactly. Most of the time, we don't actually need it. And second to last episode, a couple of episodes before, I think we had, was it in a trivia section? We were talking about conditional compilation. And I thought, why not pop it in there? might be super useful.
Opening the documentation. So there is something called C# preprocessor directives, which are now used. Also, Stuart showed this. They are used for file-based applications, but also, for conditional compilation, you can utilize, these are defined. For example, we know if you're running on .NET Framework, we know if we are targeting .NET Standard, we know if we are targeting .NET 6 or greater, because this is exactly what we need for the argument null exception, which is available since .NET 6
or greater. All right. So if I go here, here, right at the top, right?
Yeah.
I don't know why I can't. Anyway, maybe it looks a bit weird. No, it looks fine on your end. Okay, so now it's just just on mine, and that's not what I wanted. Oh no! So it was an if, right?
Yeah.
And if it's net.NET 6 or greater, but it's actually we want this to compile if it's not that, right?
Yeah.
So maybe I can have. And I don't have any autocompletion, so I'm gonna.
You don't? Otherwise, I shall.
I'm gonna have a typo. Yes, copy it.
Semi-autocomplete.
Thank you. And then down here we need to have the end if.
Yes. And now this block should only be included for if you target .NET 5 or lower, or any .NET Standard or any .NET Framework. And let's see, we're now on .NET Standard 2.0. Well, it looks unchanged. If we jump into the .NET 10 target, where this method is available, it's now grayed out. So this code, because we now actually compile our library 3 times, .NET 10, .NET 8, and .NET Standard 2.0. And this code will only be included in the .NET Standard 2.0 target. It will not be there in the other 2. So because it's already in the base class library. So for these targets where we don't need it, we just made the library a little bit smaller because it's not needed.
Amazing. All right. Now,
I think I just realized the name. Is it Cozy? I think it's Cozy. Is it? Anyway, it's the third or fourth pronunciation of Advent of Code. We haven't.
Yeah, we haven't done Advent of Code yet.
We haven't done the Advent of Code yet, but
I have done it in my not on stream, offline. But cool. I never managed to get through. Like at some point, I just always forget, and then I'm like, oh, I already broke my streak, and then I say I'll just do it next year.
Well, I have never really. I'm like. Well, when it comes to video games, I still play them myself, and I don't watch streamers playing video games. However, when it comes to Advent of Code, I don't do it myself. Actually, last year, Jason Bock, let's see if we find his YouTube channel quickly, did a playthrough of the Advent of Code. And I was I'm not sure if I find the video immediately, but I'm linking his YouTube channel. He did last year a playthrough. Maybe there's more. I need to watch out for that. Ooh!
Oh,
yes, he is.
Amazing! We totally have to watch that then. That's good. Yeah. That's nice because then I feel like I'm learning something. I feel like I'm doing it, but yeah, if I can't get stuck.
Yeah. It's my favorite kind of playthroughs.
Yeah.
Okay. Cool. Oh yeah, we still have to deal with the attributes, right?
We could deal with them now, sure. I was thinking because yeah, I mean.
No, go ahead.
No, I was just thinking if I have to, because how do I use this at work or something? Do I have to copy paste kind of this into every single project? That might be a little bit tedious.
Pretty much. Right? In particular, also when it comes, because it's not only this singular method. Well, there is a helper method, and also considering the attributes, because essentially for the attributes we kind of need to do the same now. So I'll just go attribute, basically do essentially the same.
Mm-hmm.
To also let's call these attributes. Pasting the attributes that we are missing as well, since they also need to be available, but they aren't in all versions. So let's bring them in.
Nice.
Wait a second. This one is in the system namespace. And I think, screen just turned black. Oh, there it's back.
Hi, Swoop.
Oh, it was a little
surprise.
A little, yeah. Don't fail on me now. And it does not return attribute. So, oh, wait a second. I should have copied the namespace as well. And attributes. Wait a second. This is the nullable attribute. I did make a mistake. This It's also in system diagnostics code. It's not in system, but in system diagnostics code analysis. This is where the nullable attributes live in. Yeah, because we kind of need to polyfill these as well. Well, we actually now would need to go into these attributes. I think they are available since .NET Core 3.1 or something. And this one is available since .NET 5. I may mix things up. But for our purposes, let's make them all internal. And let's guard it similarly because we currently only need it together with our throw helper. So maybe let's do the same thing here. And now I already copied a bit more code, and the more kind of backfilling, polyfilling things we do, the more code we need to copy paste all over the place, which can get a bit tedious. But let me just get this to compile and see that the .NET standard, because we earlier still saw that we were missing the attribute. Yes, so we need the analysis. Okay, let's bring back all of the attributes. This one is in a different namespace. Okay, and now if we run, our application is still targeting .NET Framework, so we will select the net standard typo 2.0 version of our library. So now this attributes should be polyfilled as well, and we should get the proper exception with the proper. Oh, it doesn't. Interesting. Oh no, actually, there it is. Parameter name is text2. So it now works.
Now it's
all
perfect.
Is but yeah, it's kind of tedious. Yeah, but now for every net standard or for every target that is less than 6.0, because I love these full helpers, and there is many more. There is like for argument out of range exceptions, and I think added in .NET 8.9 something. There is a bunch of them. Throw if equals, throw if if a number is negative, if you don't want to pass in negative numbers and such. And there is quite a bunch of these throw helpers. I think there is also on disposable, on the object disposed exception, there's also a throw if helper. So those throw helpers and exceptions are quite common, but they haven't existed in that standard or in all the target frameworks.
Yeah, so if we build a library, then we can't really use them unless we want to write a lot of extra code.
Oh yeah.
What could we do?
What could we do?
What could we do? What could you and I do on this stream to help that?
I wonder which tool we could be using.
I wonder. Well, the solution is, of course, you might have guessed it already if you know us. It's a source generator.
Yes. So we're gonna build a polyfilling source generator that will generate this throw helper if it's missing for you, and then this scheme, this kind of infrastructure, we could then extend to basically use for any throw helper, so even for any polyfilling for the degree that we want to do, which is the essence of polyfilling. We have a lower target framework where specific type or method doesn't exist yet, but we want to bring it back for some compatibility in here as well. without writing any code myself, because I'm lazy and make typos all the time. And if I write the code, kind of also then need to test it, right? If I don't write the code and have a generator created for me, I don't need to write any tests for it.
Exactly. Win-win. All right.
Cool. All right. So let's jump into our Roslyn project.
Yep.
So I'm set here a library targeting NetStandard 2.0. I think this, we always were mentioning on the stream that when you build a Roslyn component like analyzers, source generators, you need to target NetStandard 2.0. I think that, well, this was, I mean, Wider's backend is running on .NET Core. I'm not sure if they're already running Net 10, but I can imagine. But Visual Studio, based on .NET Framework, so their Roslyn engine was powered by, .NET Framework. So in order to get a Roslyn component working on all potential hosts, on all potential IDEs, .NET Standard 2.0 is the lowest common denominator. I think this restriction is now to some degree lifted. I think that in Visual Studio, we could use, I don't think their out-of-process Roslyn host is .NET 10 yet. I'm not sure. I haven't looked into it all too much. I tested it briefly. The Visual Studio, I was building a Net 9 component and it worked. The editor experience wasn't too great yet, but it worked. So tooling is kind of, Visual Studio was a bit based on .NET Framework, was a bit behind there. It's catching up now. So I think it's in general still a recommendation to target NetStandard 2.0. But I can imagine where I'm trying to get it. Long story short, I think that this restriction is lifted soon, whatever soon means. But it is on the horizon that I think that this recommendation will be. Excuse me?
It might be underneath the Christmas tree.
I'm not sure if it's that quick, but maybe on next year's Christmas tree.
Ah, nice.
But I think for now, to have best compatibility, I think it's still recommended or suggested. But sooner or later, I think this will be gone. Okay, what else do we got? Well, we are targeting, we don't need that package. We are using Microsoft.Code-Analysis.C#, which is quite literally the Roslyn compiler for the C# language. And we can use the compiler APIs to build a source generator. So it kind of analyzes the project that it is used in and can then, based on this information, emit new C# code. We also have an analyzer. This is a kind of a meta-analyzer. This analyzer helps with building analyzers and generators and all of the Roslyn components. But this is essentially the kind of the Roslyn dependency. Now, we're using the latest version of the Roslyn compiler, 5.0. So you'll need at least the .NET 10 SDK for this to work. And if you're on Visual Studio, you need the latest Visual Studio 18.0 for this to work. We could choose an earlier version to, for example, also make this compatible with .NET 8 and earlier versions of Visual Studio, 17.8 something. But yeah, for now, for demo purposes, let's not talk about targeting too much because I think Cozy is alluding to it. Looking forward to C# Advent post. I think on the 25th, I have a slot for a post, and I'll be talking a lot about what the meaning of this version is and what effect it has on the consumer's pipeline. All of the targeting stuff when it comes to Roslyn components. So I don't want to spoil too much here. So let's lose latest to with all of the features available, and let's build our source generator. Let's call it the polyfiller. Is this a component that polyfills? Not sure, but let's.
Yes.
When it comes to generator, we need to implement the incremental generator interface. Mm-hmm. I like to make my types sealed. Let's implement this interface. We only have the initialize method. What we also need to do so that the host, in our case, Wider is the host. If you're on a Visual Studio is the host. So whoever is hosting the compiler, when you do a .NET build or the command line, then the .NET SDK is the host. In order for the host to find this generator, we also put an attribute on top, the generator attribute, which per default uses is for the C# language. If we take a look at this property, it has a parameterless constructor that is saying the C# language. Because we could technically also write a generator for Visual Basic, because Roslyn is the compiler for both C# and Visual Basic. So we could either just say generator, which implicitly means this is a C# generator, or we could also be explicit about it. This is a C# generator. So a Visual Basic project, this is why we need this attribute, a Visual Basic project now sees, okay, there is a generator, but it's not emitting Visual Basic code. So I shouldn't run it because it will emit code that I cannot compile. And yeah, let's implement this initialize method. For now, we are not using too much other context. The thing about an incremental generator is you build up a pipeline. We will later have some more steps. We will just start rather simple for the beginning. So we will just say context dot register source output. And for that, we need something called the value provider. So this pipeline that we build up, let's not think about this currently too much. We'll a little bit later use this more actively. And we can have an execute method or a lambda, and my alt enter doesn't work. Does it mean I need to write it by hand? Oh, yeah, now I'm going to embarrass myself.
Does mine work? No. Sorry.
Does it work for you?
No. But can you right click and do that?
Show context actions. Context. Ah, interesting. Oh, yes, I can. Cool. Thank you so much. Let's wait a second. This is a syntax provider. Oh, this doesn't work like that, does it? No, it does not. Let's use something else. Let's use pass options provider. We need just something. Now with this context, there is now the method called add source. And this is really where we emit some text that is then compiled together with the existing code. So in the case of our library, if this method for if null isn't there, then we will just emit the C# text as if we were writing it ourselves, but now the source generator is writing it for us, and then it's compiled together with the rest of the code, which is then using it. And we pass two things. We will pass a name of this document. It's not necessarily a file. Per default, source generator files are not emitted to disk, so you don't really see them on disk. But we still give them a so-called hint name, so that tooling kind of like Wider can show something that we can click on, and it looks like a C# file, but it isn't necessarily on disk. So let's call this the polyfill.g.cs. When we have generated files, we always have the .g prefix before the CS, or we could also be more verbose and say generated. .g.cs or .generated CSS. It's a generated file. The user hasn't written it. And with generated files, we don't want to apply any analyzers because the user couldn't really edit this code because it's not the user who wrote the code, but some generator. So we don't want to write one code analysis on generated code. And then effectively we want to emit the source code. We can use like something like a string builder in order to, there is various version methods of how you create this C# text that you're gonna eventually emit. Well, maybe as a short example, maybe let's just emit a comment. So calling it hello world and just seeing if it works. Let's go to our library. I'll just briefly jump into, we need to include this generator in our library. And if we build it, kind of should already, may already, hopefully, unless I missed something, maybe we need to restart the engine because we just added it as a new reference.
It's actually, while you're doing this, something came to mind. I think this is the first time, this year at least, that we started writing code.
Oh no, without a test.
Without a test. We are very dedicated, test-driven developers, but not today.
No, we will be.
Yes.
I just want to get
something,
a heartbeat, and then you're right. Then let's write a test. I'm uncertain why it doesn't. Maybe I'm just trying to reload the project. Usually this works, but I guess not during a live demo.
No, it will work.
Or I made a mistake in the generator.
Oops.
I can't spot a mistake necessarily.
Did we once do we did a unload, reload type thing as well?
Yeah, maybe let's give that.
That worked.
Oh, let's just reload everything. Oh, there's a problem. But that's a test project. Some version. Oh, yeah. Okay, our test project has a problem. But this shouldn't result in any issues of our non-test projects. Let's see. Well, it's a warning, but it does compile. Oh, that's embarrassing. Why does this not emit? There should be a tab now, source generators, showing us that it is indeed emitting the source code. Oh, interesting.
Oh.
So it worked for the sample, but it doesn't, for some reason, doesn't work for the library. Interesting. Interesting. I'm a bit uncertain what I did wrong, but okay. I somewhere made a embarrassing mistake apparently, but let's act now as our sample will be our project. So maybe let's do multi-targeting on this application and same targeted for 10.0 and net framework. And okay, for the time being, I'll bring back this functionality into the sample itself, because I made some mistake somewhere. And okay, well, we see .NET Framework methods are not available, but yeah, let's get it fixed along the way. But what we do see is that we have a source generator kicking in, and it's indeed emitting the string that we just asked it to generate.
Nice.
But yeah, you're absolutely right. Well, this is what LLMs usually say, right? We need a test. polyfiller tests. There's also different ways. So there is different ways of how you emit the C# code. You need eventually some C# string. So you could use a string builder or some templating engine like Scriven. For testing, there's also different ways of how to test a generator. There is a library called Verify, which essentially compares the output of the test against the text file you stored on disk. There's some, how's that called? Snapshot testing. Or there is also a library from Microsoft that we are going to use now here.
Nice.
Always forget the syntax. So let's go take a peek at the documentation. We can use something, well, documentation is for analyzers, but it works the same for generators. So there should be something in this namespace. Let's write our first fact. Test 1, yeah, that's good. And there is a C# source generator test. Yeah, maybe let's use a using on that. And the C# source generator test is generic of the generator that we are testing, our polyfiller. We also need a verifier. We will use the default verifier. Yeah, this is how this testing framework works. So we'll create an instance of this. And now we can set up our we can arrange our test. So we could say, well, actually, what do we really need to arrange? We don't really have any input because we just generate new code. We could have a generator that what we could do technically is we could write maybe something like make this type partial and then have a partial method. And now have a source generator implementing this partial method. So now the source generator needs to understand, basically needs to find this method and then emit the implementation part of this method. So what the generator then essentially would be doing, oops, the partial needs to go in here. Now let's assume this is generated code, would be emitting the other part of this type and actually with the implementation of this method. And what am I doing wrong? Also, because it's static, not static. There we go. So we just declared it here, and then we could have the source generator actually implement this method. So for this case, for the setup, we would need to define, basically, we say the input to the generator. We have this partial type and this partial method. Maybe we also planned some attribute on it, which could now say, well, fun fact is actually how the regex generator works. So we can say generated regex. We pass in our pattern. My regex is not good. If we can say .cs VB, I think, I'm not entirely certain, but I think this is the regex pattern for basically we need a star. Basically finding everything that ends in .cs or VB, so essentially finding for C# or Visual Basic files. And this returns a regex, and it doesn't work because the pattern is invalid. Okay, cool. Yeah, my regex is really bad. Okay, let's just say our pattern here. So it's actually now, I'm not delivering this implementation. It's actually now a generator writing the implementation of this regex for us. And the regex source generator is actually looking for methods that have this attribute on it. And then for this pattern, implement a partial method that returns a regex, a cached regex, that does this regular pattern matching. And this generator now needs, well, basically this and this as an input in order then to generate the code. For our throw if null, we just generate it. So for our test, we don't really have an input. Long story short, this is essentially where I'm trying to get at. So we don't really have an input. If we had an input, we could say, we could add some test code and just specify some C# code, namespace, our namespace. Internal static class, our type. But yeah, in our case, it doesn't really matter. We don't really have an input. We just want to verify the output. And we should be able to do that by checking the generated sources. Test state dot generated sources. And we will add a generated source. Now this takes a couple of arguments. It takes the generator type, the file name. Well, this file name is not correct in this context. It's the hint name, but it's a type that's used for more than just source generators. And the actual content that we expect. So let's add exactly that. Type of our polyfiller. The hint name, we had polyfill generator.cs, if I recall correctly, and the hello world. Cool.
Well,
and
yeah.
Yeah?
Yeah, I mean, that's what you wrote now, but actually our polyfiller should generate the extension methods, right?
Yes, indeed. But let's see if this test works.
I'm getting ahead of myself. Let's have a heartbeat.
No, but you're absolutely right. And now let's make a mistake and see it fail. And then, yes, okay, cool. Now, would you mind making this actually verify what we need it to verify?
Yeah. So that would be all of everything that's in the extensions, right? Because I'm now a little bit. Do we need the attributes as well?
We need the attributes as well. Yeah.
Okay. So and the conditional compilation.
Let's put it all in. Yeah.
Let's put it all in because we don't know.
In the meantime, I see your salty devil is here. Thank you so much for joining.
Hello, welcome. Let me try and make enough raw string literals for everything. Okay, so that's the first part.
This is what I love raw string literals for. I think they have been made for testing source generators and for emitting C# code. Yeah.
Yes, they've been made for us for sure. And then also all of the attributes. Actually,
I think the different file. Just put them below.
Yeah, just everything in here. And where am I? Here. Yes. Woohoo!
Cool. So we see that these are in the correct namespaces. I will now actually, for this, was missing the namespace. So this should be in a namespace called system. Because the argument null exception is in the namespace called system. And there may now be a parenthesis error. Well, we will see then during.
Exactly.
There was indeed compilation. Okay, cool. Let's run the test and see it fail dramatically. If it doesn't compile, then we get some problem. Okay, it doesn't compile.
And is this okay? Let's see if it. Yes, perfect.
Yeah, it does say. I will put this into a new window just briefly so that we can view the full output with a little bit less zoom. And what it does is essentially like creating a diff syntax. So it says we see a minus before what was missing, and a plus for what was emitted but was not expected. So we have a hello world too much and the rest too little. So yeah, the test works. And now it's time to implement it.
Cool. But is this really what we expect as well? Because isn't this like this is all like it's generated. It's a generated file. So do we not also need this? I can't speak. Auto-generated attribute as well on the top.
Yeah,
Or
we
am I
will
wrong?
we will add then more stuff on top.
Okay.
But let's
So
do
for
this
now, we
afterwards.
just want to.
Yeah.
Okay.
So the generated code it's not perfect just yet. It
Yeah.
will be.
Okay.
So
I'll hold you to that.
Yeah.
We will sit here. Yep.
We could use a string builder to build up this text. We could use an engine like a templating engine like Scriven. What I like to use is the indented text writer, which is very similar to a string builder, but it allows indentation. So when we have an opening parentheses, then parenthesis, then the next line is indented, like something like this, and we don't need to worry about the spaces too much. And well, technically, we could emit just a single line of code, but yeah, nobody will be able to read that. So we have our writer. Now the string writer needs a text writer. We will use a string writer. Let's actually call this writer. And let's call this text. And this is disposable, so we need a using. And then instead of emitting here, we will say writer.toString. And now we use the text in order to build up our code. Oops. And I suppose we can do white lines, and let's just paste in the code again.
Yeah.
As an actual what we're actually emitting.
Okay.
Do you maybe still have that in your clipboard?
I have it with the rostering glitches though. Woohoo! Did that work?
Cool. Guess we need to tinker with the spacing, because what the test is doing, it's spacing sensitive.
Sorry.
So it must need no worries. This is what
happens when you let me copy paste.
No, it's all good. For some reason, writer is doing spaces instead of tabs, although we set it to tabs for our war strings. So this needs to be perfect match. Okay, now I'm mixing up the. If you spot, actually, what we can do, there's a cool feature of writer. We can say
yes,
lang equals C#, and now this will be rendered as if it was C#, but it's still just a string. So maybe we now detect errors more quickly. Okay, namespace, class, extension block. We have our method. We need the other method. We need to fix the spacing. And this is closing the extension block. This is closing the class. This is closing the namespace. Then we have the other namespace with these attributes. And one more namespace with the caller argument expression. Damn it, do I now need to do the same again for the expectation as well? Okay, but that looks good. I'll just paste this into, because the spacing now will be wrong and the test will fail because it's space sensitive. It doesn't do a syntactic, it doesn't do a semantic check, but a syntactic check. So it matches all the spaces. So just, okay. Which now definitely means this should pass because we just pasted in the sync code twice. And interestingly, it fails. Let's see.
Yeah.
Oh, okay. There is a missing final new line in our expectation.
Classic.
So now this should turn green. No. Oh, we have 6 diagnostics. Why do we have 6 diagnostics? The type or namespace name not null could not be found. Oh, yes, I see. Because, well, we are saying not null here.
Yeah.
But we don't have any usings or anything whatsoever.
Ah.
So this not null, because this not null lives in a different namespace, I will go ahead and use the full namespace for now. But the caller argument, so these are here, and this one is in here. Let's see, this should but the spacing is off here. So let's again maybe go back to the polyfiller. Nice. Now the namespaces should be right. Okay, so the C# code was correct, but it wasn't successfully compiling. Well, now it is. So if we run that and rerun our generator, I hope that it works. Oh yeah, some leftovers because we moved code around. And let's see if indeed, there it is. Now our polyfill.generator.cs now is emitting this code. So on our disk, we only have the program and this our type. And if we go to the our type and switch over, well, it works for net 10. And if we switch over to net framework, it still works. And the cool thing is if we have 12-bit here, we're not jumping to the BCL because there is no BCL. We should now be jumping to our source generated code. And there it is. It also says there's reader mode. If I try to edit this, where it says, wait a second, you're trying to edit source generated code. This doesn't really exist on disk. It's just somewhere generated code that was compiled together with our code. And we have now, with a source generator, emitted a extension member that polyfills the throw if null exception helper. I'm not sure if this sentence made sense.
It definitely made sense. I love it. But yeah, I guess because you can't really edit this code and well, it's emitted, it's generated. I think I really want to add those like auto-generated attribute and clean it up a little bit as well.
Oh yes. Eric mentioning is that our examples are interesting and our duck presentation comes to mind. I don't have a duck. I'm not sure.
You don't have a duck
after traveling, but I don't have them in range. Yeah.
Stefan is the guardians of our ducks. Yeah, we're really cool. Talk about involving a lot of ducks.
Yeah.
And we traveled with them to two different countries, and I always feel like it must be so funny to work at the airport and then just see people arrive with the suitcase full of ducks.
What is he up to?
It's suspicious. We're definitely on some lists now.
Oh yeah. Would you mind making this code more generated, more generate-y? Since we're not following all the best practices of source generated code yet, what you were alluding to.
Exactly. Right at the top, we need. I know this. Oops. This is why I shouldn't do it because I mess up all the styling. But we need this auto-generated tag, I guess. I remember that because we once built what was it called? a global using thing. We we globalized a globalizer.
Yes. Yeah.
We globalized all of the duplicate usings, and we spent a lot of episodes with all the exceptions. So because you wouldn't want to globalize any usings from that. So I'd definitely remember this tag or attribute for the rest of my life. And I guess what else do we need?
It's also so we need to tell. This is just another way. So for tooling that observes the file name, we tell it's a generated file by the file name or by this hint name. For tooling that just reads the text, it's basically this comment saying on top, this is generated code. When we are in a generated context, which we are, nullable reference types are disabled. So currently, this question mark doesn't really have,
okay, so we need
work as it would be expected.
So we need a nullable enable. Oops.
Yes.
Right?
Yeah. Because per default, generated code is ignoring the project level setting of nullability. So yeah, basically those are the two headers you usually see with every generated code, auto-generated and nullable enable. Yes. Then with generated code, the thing is about generated code, we just generate the code, but we don't know where it is generated in. So for example, what we now see here, argument null exception. What if the user has a global using in their project? Let's actually, maybe we can quickly cause a, I'm not sure if we are able to cause a problem.
We definitely are.
let's see if it actually fails. Let's call it conflict. So if we had here, okay, this namespace. Now
it wouldn't be Christmas without some conflict. So.
Let's also make this a global using and define our own argument null exception. Let me copy paste it.
Yeah.
In here, yes. Now building this. Well, okay, we have a problem here because we now have two in the context, so we don't know. So let's disambiguate it and say system dot. Well, I can imagine that the generated code will not fail because we are in the system namespace. Because the generated code here is now, I think, this is how the rules of C#, if I recall correctly. This is now using the system null reference exception because we are in the system namespace. If we were referring to a different type, so I can't really think of a real example right now. What I was trying to allude to is that, argument null exception isn't necessarily argument null exception. So it could be, depending on the context, another argument null exception, just a different type of the same name. So we want to be very explicit about it. And usually what we see in source generated context code is we don't really have, oops, now I was trying to edit a generated file. What we usually see in generated code is not using declarations, but we usually then use the fully qualified name of the types, as well as escaping it with the global, using the global namespace alias to essentially disregard any project level using. So just to make sure that it is the type that we intended it to be, if that made sense. So we want to, whenever we use a type, we want to use the full global alias qualified name.
Got it. Right. Okay. And so where do we have that?
So we have a type name here.
Oh yeah. So I just need the global in front of it. Is that right?
And the full namespace. So system dot, because the argument null exception is in system dot. So yeah, here we already started with it. So I'm just adding a global colon here. Same with the caller argument exception, exactly, expression. Where else do we use type names? Well, with string, this is a language name. That's cool. If we were using the type names string, then we would need to say global colon system dot string. But since when we use the language name, that's unambiguously system dot string, so that's fine. But yeah, you're already pointing at the right spot. And then we throw a new argument null exception. So this should also be the global alias.
Global system dot.
Exactly. Okay. And yeah, now we need to do this for the rest as well. Like attribute usage, I think that's also in global colon system.
Okay.
Attribute targets, same thing. So we kind of, repeat this pattern.
Yeah.
If we would go ahead, I'll do the attributes below. So with every type name, and then we have one more here. And well, that's an attribute. There is another one. I think we didn't know that one. Yeah.
Whoops.
And I always forget it myself. And I think, this should be it. So this is usually how generated code looks like. It has like the full name. And because, well, you don't really know where you're generating this code into. If, what I was trying to allude to, if the project has some global usings, or maybe this project does not have some global usings that you would expect, because, well, every newer project has implicit usings enabled. That means system is automatically there. But what if the user disables it, and our generated code now required this using to be globally defined, but now it's not. So now the user's project will fail because we emitted code that isn't using the system anymore. So just to be as independable of the project we are generating into, we're trying to be as explicit with the type names as we can. And there is one last thing missing when it comes to generated code. Yes, we do have the auto-generated comment on top, but that's just a comment. Comment is trivia. When we compile an application, trivia, such as comments, are gone. So if we have a tool, because maybe you don't have a source-based tool, maybe you have a reflection-based tool that is analyzing a DLL or a library all by reflection. But with reflection in IL code, there are no comments. So this auto-generated comment is gone. So we need a specific attribute in order for reflection-based tools to tell them this is a generated type. Do you know that?
No.
No?
Does the audience know it? Do I know it actually? Is it something I should know?
If you look at in our notes, the last block. No, the second to last block at the end.
Oh my God. No, I don't know it.
Well, I always forget the exact syntax as well, so I'm just copy pasting it. The generated code attribute. And the generated code attribute is an attribute that takes two strings, the name of the tool that generated this code. In our case, we will use the namespace of the...
yes.
Actually, this is wrong. This should be called our generator compatibility.
Yeah.
Compatibility. And also, so this will be the first pre-release that we're gonna release after the stream, then on NuGet. So we also have a version. So we have a tool name and a version. And well, this type is generated. If we put it on the type, I don't think we need to put it on the members. So this is fine. Here is another type. Oops, actually I should copy this here. And here is another type, and here is another type. And here is another type. Cool. And I think now we adhered to all of the code generation best practices. Let's build it and see if we indeed get as a result. And yeah, I'm not sure why there's 2 nodes.
Yeah.
But they are both, okay, they've got both updated. Totally uncertain. Maybe a rendering bug. But yeah, okay, here's our generated file. First of all, .generated.cs, auto-generated comment, generated attributes, generated all over the place, full names, and this is now properly polyfilled.
Awesome.
Method. And usually the polyfillings, we also emit them as internal. Because yeah, if we put them into a library, maybe the user doesn't want to expose this polyfilled methods. If it was a library that then is consumed by another project. So usually polyfilling is done in an internal fashion. You could, however, make it programmatic. You could maybe have some option to the generator to say, yeah, okay, per default, make this polyfill types internal. But if the user has flipped some switch, some MS build property, then make them public instead. Yeah, this is what polyfilling library or polyfilling tool could do when it comes to configuration. Well, speaking of configuration, actually, since we have a bit of time, and we never finish on time. It would be weird if we started now.
Yeah, not on the last episode. No, we're still on time. I mean, come on. We're doing really
fair,
well.
Yeah. Well, let's see.
Let's see.
Let's actually add some configuration to our generator.
Yes.
Well, maybe let's actually do this. Let's actually do this public example that we had.
Yeah.
So what we could do is in our consumer, maybe we want to observe a property. We call this make polyfilled types public. And we could set this to true. And if it is true, now we actually don't want to make them internal, but public instead. How do we do this? First of all, a source generator doesn't see an MS build property per default. We need to make this property visible to the compiler. So there is an item group, or if we define an item group, and use the property visible to property. Let's check the documentation. So there is the incremental generator cookbook, which shows some patterns how to build a incremental generator, a bit of the design and such, and where we can register some output, how to add additional files, because you could have some XML files as an input, or JSON files, or some non-C# files as an input to the generator as well, that the generator then evaluates. And there can also be properties. There we go. But per default, the properties are not visible to the compiler, so we need the compiler visible property. Now I'm doing this here manually. What we could do, we're not doing this right now, but what we could technically do, if we publish our generator as a NuGet package, we could additionally ship packages props, or a props file that is called flashover.compatibility.props, which then automatically adds this. I may have an Do I have an example? I should have an example. Because we did write the generators project some time ago. And I think in there, we also pack wonder if we can find this. Yeah, we also pack, so the NuGet package is called flashover.generators. So we can use the package name flashover.generators.props and or targets. And if we put this in the right directory, then they're automatically loaded. And in there, we could basically now ship, well, I'm shipping here interceptors preview because this was when we started with interceptors, but we could in here essentially emit this compiler is visible too, so that the user doesn't have to do it.
Okay.
Well, we could, but for now, let's do it manually. So we make polyfilling types public property visible to the compiler so that Roslyn can actually see it, and we can see it in here. Now, we also need now the reading portion of it, and this is done via the analyzer's config options provider. I'll just copy this code, put it in here. And because we see a generator has multiple values it provides, so we can have a syntax provider. The syntax provider, for example, is used by the regex generator, the example we showed earlier, so that we can look for a specific attribute. There's actually a method for that. So if you go to the syntax provider for attribute with metadata name, where we could now look for all of the, I think it's in system.regex.generated regex attribute. And now, yeah, we would be adding some more code here, but now the syntax provider, because it's checking C# syntax, would now essentially as an input filter all nodes, like in our case methods or properties that have this attribute applied. So this is what a syntactic filtering would look like. But we also can take a look at the parse options. With the parse options, we can understand, hey, what language version is the user's compilation using? Is it C#14? Is it C#7.3? Then there is additional texts, like if we have some additional text, XML files, whatever. Compilation provider, this is the counterpart to the syntax provider, because the syntax provider, that's only the C# text. So if we write system.string, that's just, well, a namespace and a type name. But the compilation provider now can actually make meaning to this so that it knows this is really the system.string type, which has a length property, the length property that we are using. This is then what the compilation provider and the so-called semantic model is adding on top of that. Then we can also take a look at metadata references. For example, other packages that we depend on or other libraries that our library depends on. And the analyzer config options provider, via which we can read some options. We pass in a provider here, and there is usually also a cancellation token. And we ask to get this build property, but our build property is called, I forgot the name already, make polyfilled types public. So we are trying to get the value of build property underscore, that's just a prefix for every MS build property, and then the name. Make public, so we then essentially get a Boolean. And if this value, because we could write any value in here. We could write hello or advent. But yeah, we want to only do it if this is set to true, so to act like a Boolean. So if this is true, then we return true. Well, otherwise false. And this would now be a options provider, which we can now use as an input to our generator. Now this is just a Boolean. So essentially, we now have a Boolean as an input. Make public. And we can now use this make public essentially for our accessibility. So let's define a string accessibility. If make public is true, then say public, otherwise internal. And now let's use interpolated raw string literals, where we can now add for the accessibility here, the accessibility. And I'm not sure if this is just rendering correctly or if it is incorrect, but it should be all right. And well, we only said make, well, we called it make polyfill types public. So just for demo purposes, let's not do it on the types. Set the accessibility. Cool. So if we run, I want to know if it actually works.
Yeah.
So let's build the entire project. Let's see that we still get the very same string. Oh. Uh-oh.
Oh. Okay.
Did we mess? Maybe we messed something up. Very much possible.
But it's only one file now, so that's something.
Yeah, but it's empty.
Yeah. Well, you can't have everything.
Could be that the generator is crashing. Let's see if we have $2. So that means that when we have double, it's escaped. So this should be the accessibility string. Yeah, actually agreed. Not sure what I am missing.
So weird.
Did you notice something?
No, I'm just wondering, because if there was something wrong with that, I guess we would get the wrong code generated, right? But we got nothing generated, so...
Yeah, if there's nothing, it could be that the source generator is crashing.
Yeah.
And then nothing gets emitted. So I wonder if it actually is... Wait a second, something's off here. Interesting. Is it just for the .NET? Okay, now okay, I'm totally uncertain. Anyway, it's public now. Now, if we were to go ahead, now I'm wondering, I hope this works. So looking at this public, this should not turn into internal if we essentially make this false or anything else, because we are only listening for true. So maybe let's make this, well, let's make it advent. Or, well, we could remove it. We could also remove it entirely. So now, if everything works as expected, now the source generator
there it is,
understood the change and made it internal. And that's the cool thing about the incremental generator, because the incremental generator only regenerates when it has to. In our pipeline, as an input, we essentially only have, well, we see our input is not a Boolean. It's an incremental value provider of Boolean. So this is just a pipeline that we will build up that is later then executed. You can think of this is very link-like. When we write a link expression, where select greater than, no, this doesn't exist, but yeah. If it's a pipeline that we build up, creating an enumerable and another enumerable, it's not executed immediately. It's only executed when we iterate through it or when we materialize it via toArray, or if we have an enumerable of ints, then we can say sum on it. Only then this link engine is executed. And this is similar with generators. Not the same, but quite similar. We build up a pipeline, and every step on the pipeline essentially has a cache. So if it runs again, well, if it runs the first time, it will take a look at the values, cache these values. I think this is called memorization. And when it runs again, it will see has been to a specific step the input the same as last time. Well, same input. Generators should be deterministic, so same input, same output. This step doesn't execute, but will just return the previously returned result and will not generate code again. So there's some short-circuit optimizations going on. If we wouldn't have this optimization, we would need to regenerate the source code on every key press. In order to manifest that, let's add a little comment in here, time, and say, let's be good, dates time dot now, UTC now. So the source code will include the time at which it was generated. And this should only change when we change something along the pipeline. Well, we have a single pipeline step, which is observing this Boolean. So if this Boolean flips from true to false or false to true, then it should regenerate the code, but not on every key press anywhere, which is essentially what's going to happen. So, well, it depends on the host, whenever the host is rerunning the generator, but it could be on every key press, maybe debounced. So when we type new code and then hold for a second, then it could regenerate the code. I'm not sure how wide it does it, but sooner or later we'll build our own tool. Then we need to think about stuff like that. Oh, but I'm teasing already. Anyway, let's see if the time gets emitted. There we go. If we now jump into our project. And okay, now let's open some inputs. We have at the bottom essentially our inputs, so our project and some C# code. We have 195308. If I'm writing some text here, C# Advent Calendar 2025, I save. This time shouldn't change, because in the pipeline we observe this MS-build property, but this MS-build property is still not true. So nothing, the generator, although running again, understood that along the pipeline we have hit a node where we already received the same input, so it just reused the same output. Now the generator itself is not running again. Now if we change this make polyfilled types, changing this to public, now there is actually a change along the line, and this time now should change, and it just
there
did.
It is.
And indeed generated new code, because the public is now no longer public. The internal is no longer internal but public. And likewise, if we change it back to false, then it will take just whatever time the tool takes to regenerate the code, and it's internal, and we got a new version of the source code. And that's the real power of the incremental generator, because if it wasn't incremental, essentially every key press, or every time we save, or depending on how the tool is implemented, would need to regenerate our code. And if we have a huge solution, then the developer experience isn't too great.
Yeah, fair enough. Awesome. So now we've got our polyfilling source generator. We can make our generated code public or internal.
Do we want to add another option, or do we want to finish on time?
What would be the? It's a tough question. Do we have to? Is the C# Advent? We can take however long we like, right?
Yeah. I believe so. Yeah.
Well, in that case, what would you add if you could add something?
Because currently there isn't. Because the intention I have for this project, that we have for this project, is that we're gonna add more polyfillings to it. Currently, it only polyfills the throw if now. Maybe we add all of the throw helpers and add additional things. So this could be a huge project. To be fair, an existing project exists already, so we're kind of limiting that. There is actually from Simon Kropp called polyfill. This doesn't use source generators. This is using, how is this called? Content-based. This is a content-based package. So depending on the configuration that you're using, it's essentially placing a C# file into your compilation or not. This is not source generator based. Well, technically, this is a bit more efficient because there is less code running, but it's also less configurable because you either move in this C# file to polyfill or you don't. So with configuration, you can only do so much. The other approach would be the generator. So there is polysharp, which is from somebody of the .NET team. Not sure from the Roslyn team, but from the .NET team. And this is a Roslyn-based source generator. And they actually implemented quite a lot already. So they have polyfillings for the nullability attributes, index in the range that we need when we have something like the backtick 1 or the range syntax. Unscoped ref attribute. You rarely need this, but I love it. The caller argument expression attribute that we're also using, a bunch of more attributes like the collection builder attribute that you need in order to build your own for like our collection to have to allow collection expressions to for a custom collection and so on. I'm not looking. Okay, it doesn't emit the throw helpers yet, but with C# 14, it may only be a matter of days or weeks. Or essentially, well, actually noticed it's not doing it yet. So I guess was the motivation for us to to not build it ourselves. And if there is a lot of stuff that it polyfills, maybe you don't want to polyfill all of it. Maybe you just want to polyfill a subset of it. So we could have some configuration to say, okay, I only specify a specific subset that I'd leak because I was using a type. Now I'm targeting .NET Standard doesn't exist, and I explicitly want to polyfill this singular type. So we could, again, very similarly.
Could add this, But how do we test it? Because we're currently only polyfilling one thing. So,
well, we could also.
And then we have the empty file, but then we don't know if it's if it's a bug or if it's right.
That's also fair. Well, we also have attributes. We actually already have attributes, so we could split it up to polyfill these attributes individually. But if this argument null exception, or actually this throw if null is emitted, then we need to emit the attributes as well, otherwise it wouldn't work. So we need some
mechanism. We can try and emit just attributes, no throw if null. Okay, exactly. Let's do that then.
So what we could do is essentially something like we could build ourselves a little enum. Let's call it polyfill
enum.
Well, it's polyfills.
Okay.
Which we can make a flags enum, so it can assume more or less multiple values. Well, it's still just backed by a good old integer, but with some bit magic, we can essentially have multiple values. So maybe let's say the not null attribute. Or do we want to be super specific? System, not. No, actually, is it in system? No, it's not in system. I always forget what namespaces they are. Maybe let's go through. So we have system, one-time compiler services, caller argument expression attribute. Oops. Then we have in this namespace, system diagnostics code analysis, not null attribute, and the does not return attribute, and of course the system argument null exception for if null method.
Yep.
Now, since we want to make this a flags thing, we need to give them values, and we can do this by if we use binary increasing values. So let's say 1, 2, 4, 8. I think we could also do bit shifting by doing something like this. 2, 3, 4. This essentially means 1. This means 2. This means 4. This means 8, if I'm not mistaken. I may be. Let's briefly lab.razor.fyi this. If my internet does not forsake me.
What? Usually it's just my internet. First.
So this should be compile. Yes, please. Okay, so maybe sharplab faster, or requires maybe a little bit less resources. Oh, yeah. That's actually 2. My bad. So okay, 0 is 1. 1 is 2. 4, 3. Okay, cool. So 1 actually already is 2. My bad. So we need to start at 0. 0, 1, 2, 4. Well, 3. And we could also have a none, which is 0. And we could have an all, which is now a combination of all of them. So it's, we do now some bit magic here.
Isn't that the pipe?
Yeah, so that's a binary OR.
Yeah.
And essentially how this works, so if we have 0, then that's none.
Yeah.
If we have 1, that's throw if null. If we have 2, that's not null attribute. If we have 3, that's essentially, well, what is 3? 3 is 1 plus 2. So it's for if null and not null attribute. This is based on binary logic. So, well, 0 is 0. 1 in binary is 1. 2 is 1, 0. 3 is 1, 1. And 4 would be 1, 0, 0. And essentially by the bits, so we say, if we see for, essentially for 3, this is 3, we see that both bits are set. Well, actually, we have some leading zeros as well. It's a 32-bit integer, so we have a lot of leading zeros. we see that this bit is on, therefore, for if null. We see this bit is on, therefore, not null attribute. We see the third bit, it's not on, so it's not, so does not include, does not return is not included, and so on. Now, if we have 1, 0, 0, or in our case, since we have essentially 4 values, 0, 1, 0, 0, that means only include that does not return attribute. And if we had 1, 0, 0, 0, that means only include this attribute. But if all are set, that means all of them. And with this binary OR, we essentially made this a synonym. Because if we have 0, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, and 1, 0, 0, 0, where the first one is the first one, the second one is the second entry, the third is the third entry, because 0, 1, 0, 0 in binary equals 4, 1, 0, 0, 0, 0 in binary equals 8. And if we now OR combine them, which is just saying it's like a logical OR, only one of them has to be true. So we look at this column, we have at least 1, 1. So this turns to 1. Then we take a look at the second column. There is a 1, therefore it turns to 1. We look at the third column. There is a 1, therefore it turns to 1. We in the third, there is a 1, 1, and now we essentially have 15. All our bits are set, which is now the synonym to all.
Nice. Okay.
Because it's 8 plus 4 plus 2 plus 1. Oh, plus, not multiplied. Plus 4 plus 2 plus 1. And this is how flags work under the hood. So they're still actually just an integer, but by the value in bit representation, we can actually not abuse it, but use it efficiently, essentially efficiently storing multiple booleans together in a singular type that also has a name and nice meaning.
Cool. Awesome.
So cool. And we could use another type and essentially see what the user configures, then essentially flip the bits if it's configured, and if it's not configured, and then generate for those which are active. So I guess, again, we need to have a provider here. How do we do that? Well, we essentially need to observe this is essentially our make public provider. Then we could have our provider that makes the polyfills, enum. And this one is now observing the, how do we call it? Polyfills attribute, for a lack of a better name. So we can check in the samples. We would now have another property. We call it polyfills. Or maybe let's call it include polyfills. And we make this property visible to the compiler as well. Then we need to enter values here. And we will listen to this include polyfills. This is now just a string. So we could say if the string is not, if this property does not exist, we say none. But if it does exist, we now basically need to parse this string to be an enum.
But would it not make sense to get all of them if it doesn't exist? Because if you're using the polyfilling,
yes,
you would want to at least polyfill something, right?
I guess this is now what we choose for the default to be. Yes, we could say if it's not specified, everything. But if it's specified, so if nothing is specified, it's everything. But if something is specified, it's inclusive. So an opt-in. Yeah, we could define it like that. So if you don't have anything, if you don't have anything, you get everything. But if you specify one thing, then you need to be explicit.
Yeah. So otherwise, I would think it's not working because I would just miss this attribute.
It wouldn't just do anything, yeah. Then we can use enum.parse, I hope. I guess we should use try parse, because what if the user has a bad string? Then this again needs, okay, it gets a bit confusing now. Let's use some good old if statements.
Yep.
To make this a bit more oh, there we go already. Anyway, so if this property does exist, we try to parse it, and result. And actually, yes, so if it is parsable, we return the result. What if it's invalid? Do we then want to do none or again all? So if I'm essentially like so, this is invalid.
Yeah.
So what do we do now? Maybe let's do none so that we can show that something different is happening. We will come at the end just for an example of how we could solve this then. And I think try parse works on comma separation. So yeah, I guess we would also need to do with spacing and so on, but we're not gonna deal with spacing now. Let me just briefly try something. If we have our, so if you're using this correctly, if we were having our polyfills here, and if you're saying enum.parse, not using the try variant now, polyfills. Yes. And if we now use the string, cool. And I think we need to do comma separation. Or is it semicolon, some comma separation? I'm not entirely certain. Okay, it's comma separation. So we can pass in comma separated string, and then we essentially get the enum.
Yep.
So we need in the polyfiller, yes, try parse. So this also needs to specify the, oh, we actually do that already implicitly. Okay. Yeah, this actually should be good to go. And then the thing is now we have two providers. We have the make public provider and this polyfills provider. So we need to combine them now into a new provider. We can now say the make public provider, combine it with our polyfills provider, which is now a combination of two providers. So we now, instead of a single value, get a value tuple with make public and
what else we get?
Okay. And our polyfills. And we need to give this a name, of course, source. And now here we say source.makePublic. And we also have our polyfills in source.polyfills. And then could then detect on which bit is flipped. So let's try an example of essentially, maybe let's only emit all of the attributes. Or maybe let's emit these two nullable attributes, but nothing else.
Yeah.
And well, we're now emitting them into a single file. We could also split it by multiple files, but yeah, let's not get too crazy on it. So essentially what we now need to do is, can we do this in an interpolated string? I don't think so. So I guess we need to split this up. I'll just move in. Just shuffling a bit of code around so that we can extract this into singular pieces, which we're gonna do now. So moving this out into a separate source.writeLine, text. Oops. And I failed to see the problem here. Line starts with a different white space than the closing line of the raw string. It's literal.
Oh, it's the...
Oh, wow. I don't understand. Oh, is it because...
yeah, maybe indentation is slightly wrong?
Okay, I'll stick. I really don't like the default right indentation here, but let's stick with it for now.
Yeah. All right.
Text.WriteLine. Actually, we should split this up into 2 as well. So let's copy paste this. And from the first one, from the last one, we move the first one, and from the first one, we move the last one.
Nice.
Then we have one thing that's left to go, which just moves to, oh, doesn't matter. Let's leave it as here. And I guess now we just need to if guard then. And saying if in our polyfills, okay, I now totally forgot what we said here. So this is the argument null exception one. Yep. If the polyfills, I need to think how we can check if a bit is set. I think we logically end combine this with the bits that, or with the enum value that we want to check. In our case, that's the for if null. And if we do an AND combination, AND means all of the bits must be set. So we essentially apply a mask to see if it's if this is included. And if it is, then it returns, then it assumes the value, otherwise it's 0, I think. So we then compare this against that, which is, I think, essentially now a check if this exists. Do we need to put this into parentheses? Yes.
Ah, nice.
And so we essentially said, is this bit set? And if it is, then we emit it. And we now need to do this for the rest as well. Oh, okay. We need to actually, this should always be emitted as a bit of a header. So we want to move this on out as well, which is the caller argument expression. Text.WriteLine. And if guard these as well. Would you mind helping me with the if guards? Basically doing the same as with the first one. To check if the bit is set.
Mm-hmm.
So I'll copy this as well. I will start from the bottom.
Yep.
Then we will meet in the middle. So that's the caller.
Yeah.
That's the generated. No, it's not. That's the does not return.
Oops. Oh.
It should be not null. Can you just type not null? Does it? Yes.
No.
Cool.
It's a bit funky, but I think.
Auto completion.
No.
Okay. Well, let's see if this works. It may not, but let's see. Well, I guess, yeah, we may now run into a problem, but it's fine. Oh, yes.
Oh.
Apparently, it seems to be working already.
It seems to be working.
What does it? Let's take a look at the generated code.
Yeah.
It emits. Oh,
what?
Wait. Did it generate? Maybe we need to do some. Since we changed the generator, maybe we want to reload, try to build everything and reload. And
that looks promising.
It looks promising that it doesn't work, actually, yes. But why do we see it here if it doesn't, I think this content is still outdated.
Oh my goodness.
Or we have a problem now in the generated code, and the generated code is invalid. But it doesn't look invalid. It looks all right. Well, the tooling is a bit off. It actually works as expected. So if we were to go into the sample, and because what we said, if we omit this, then everything should be emitted. Let's see if we can build it now. No. That's okay.
Broke
Maybe we
everything.
missed something. Probably,
okay, maybe we can see it quickly.
Maybe there's a mistake here, yeah. Include polyfills. Include polyfills. And we then do the dance of try parse. And else we emit all. But if it's none, we also have a time. Maybe let's need to restart the analyzers here. Maybe that does the trick.
Maybe. Okay, so but we kind of emit. Oh, nothing. Again.
So yeah.
Okay, that would also yeah.
Oh.
Oops.
How did we work around the issue earlier?
We just waited.
Because,
I think, right?
Do we have an issue with? Let's check. Does the try parse method even exist? Should, otherwise it shouldn't compile. On net standard, yes, it does. Okay, so that should be all working just fine. I am quite uncertain. If try parse, then we just return the result. Otherwise, it's none or all. Then we combine, and we run. Maybe. Quite uncertain if it's a problem with the generator or the consumer not quite working as expected.
Oh yeah, what did we put in?
I think we omitted it now, which means it should generate everything. Because if we can't find this property, this should return false. So we say all. And actually, we have a bug here. Eric actually suggests to use has flag. Oh, that's embarrassing. Okay, it's way shorter. Maybe we made a mistake there with our logic. Okay, would you mind helping me to refactor this to use has flags? I start at the bottom. Maybe.
I started.
Oh, then I go from the top. Maybe we just made a mistake there.
That would be very funny. Oh my god, sorry. Even when I'm helping, it took ages. Wait, did I miss yeah. No, did I miss 2? How many braces do we need? 1.
I think that's good, yeah.
1, 2. Okay.
I just removed the leading one because I went
Yeah,
into
thank
it
you.
myself. Okay, let's see if we build everything. We just had a problem with our logic. No. Samples. Don't include it. Let's see. That's saddening.
Yeah.
Is the try well, the try pass should be, because we just tested it, right? That should kind of parse this enum. And we should also be able to cast this to an integer to see the integral value of 3, because we combine essentially 1 and 2. And it's just comma separated. And I mean, if we were doing a try pass, the thing that we are doing, which now returns a Boolean, not polyfills. Now this is a Boolean, and this is our enum. Yeah, it's true and 3, and that does look good actually. So I'm uncertain why this does not seem to work in our generator. Go ahead.
No. I wish we could like debug it a little bit.
Well, I think one actually can, since we, let's see if this still works. You can have something, you can have launch settings, and if you put in the generator an app that's targeting the generator, an app that is using the generator, then we just may be able to. I'm wondering if this still works. Let's see. No, it doesn't, because our app doesn't compile. What if we were to remove this to at least get it to compile? Let's see if that works. Cool. Okay. So we're kind of now debugging a generator. And false. Interesting. Oh, because it's empty. Yeah, cool. Oh, wait a second. Wait a second. Although, haha, maybe I just did a misunderstanding. Although we are missing the property,
Yeah.
we actually still hit this code. So I was wrong. If this property is not found, I'm not sure when this returns actually false. So this was empty. And what happens if we try to parse empty? Well, that means it returns false. So in this case, but in that case, we would polyfill all. So we should actually, no, wait a second. We're here. Then we actually polyfill none. Haha. So maybe it was working. And we were just creating no polyfills. And maybe we fixed something with maybe the bit flipping was wrong. So if we bring that property back.
Yep.
And maybe let's actually do the one that we want to polyfill for if null.
Yep.
So let's add this one.
Yeah.
Yeah, that looks
nice.
good. It fails, but it looks good.
yeah. It fails in a good way.
It's in a good way. Because if we go to our type, and we should not be able to bring them back. So Oh yeah, but it doesn't. Yeah, it doesn't compile, so it can't work. Because what it looks like, I'm not sure why tooling is forsaking us, but it seems to work. Because if we just build it, I think it's just wider combined with food with me that something is not as we expect it to be. But we get in our sample, we actually get the type space or namespace not null attribute isn't defined. So none of these attributes, because we only emit code that requires these attributes without emitting these attributes. So I suppose to make our generator a bit more stable, we should do something like we know that if we
like we
emit
know
this one, yes.
Yeah. But like technically, I guess, because this was just kind of to show that if you have like different polyfills, you can.
Yeah.
I don't think really we would ever. Would there be a use case where we would really actually just want to emit attributes if you reuse them, maybe? Or are we just like grabbing for straws right now?
Maybe you want the attribute without the method. So maybe we want to use in our sample. Maybe we don't want to use these throw helpers, but we use the not null attribute here. Now, well, we need the using. On .NET 10, it exists. On .NET 8, it doesn't. So not null attribute. If we now go into the settings and say, please polyfill this attribute, now will it just start working? This would be cool.
Did you build it? Ah, no. Oh my god.
Should. What's interesting? It does compile. Maybe it's just wider not. Maybe if we restart wider, everything is good again. Maybe because this seems to be a theme when we have code with me for on too long, then stuff gets funky. If we do a .NET build, .NET 10 and .NET Framework succeeds. This not null attribute. If we take a look at documentation, this exists in .NET Standard 2.1, but it does not exist in .NET Framework 4.8. So it's not there. So if we were now to essentially change this, maybe to empty, so we don't polyfill anything, and rebuild, we see
destruction.
.NET Framework. Wait a second, what did we build? Wait a second. Yeah, sample. No, that's correct. I was hoping that we have some warnings. Oh, okay. Yeah, we just have some warnings for .NET 10, but .NET 10 compiles, but 4.8 fails because it's missing. So actually,
it works.
It's working, but
you just can't see it.
Our tooling setup here gets tired. But if we bring it back, now it works. So our configuration works. And I suppose what we could also do to maybe to not put it on the user to generate code correctly, or to combine those options correctly, we could say if we have the not null defined, then regardless, we should also add all of the attributes as well, because they are needed. So we essentially now have a system. We could generate those attributes individually, but if we generate something that requires these attributes, then we emit them unconditionally because they're required.
Nice.
So we could have a system like this, and now it should always compile. And if we don't specify anything, nothing will be there. But if we specify something, then whatever we specify and its dependencies will be there. And yeah, we built our own configurable polyfilling incremental source generator.
Amazing.
And now we can do argument if null. Well, if tooling wasn't forsaking us now, because it also seems to be gone on .NET 10.
We've broken .NET 10.
Yeah.
Amazing. Live here with you. Let's call the team.
I guess Weiler tells us you're over time. It's time to stop.
We are over time, as promised.
Promised.
We never disappoint in that sense. But yeah, so now all that's left is kind of, I guess polyfilling as much as we can and then releasing it, right?
Oh, yes. As version, maybe we start with a pre-release first, or where do we put this? Well, maybe we don't do a pre-release. Maybe we do a 0.1.0 for us to try out in our libraries, and maybe somebody out in the world would like to give that a try as well and give us some feedback on scenarios where it doesn't work, because we definitely missed some scenario.
Yeah, we definitely did. Yeah, and I guess, I mean, we already published some other things. Maybe we can have a quick look, because something that we also noticed that might be missing when we last did this. Right?
You mean when we take a look at the generator that we built some time ago.
Yeah.
Well, from NuGet.org, we don't really see what's in the box. Well, there is NuGet.info, or the NuGet Package Explorer, which is entirely online. So without necessarily downloading the package and bring it into our disk, we can take a look at what comes with the NuGet package. And we see, okay, there are some libraries included. Maybe let's take a look at not a custom one, but one that is used quite broadly, Microsoft.extensions.logging.abstractions. So that's logging. This package is used very broadly. We can see there is some targets. There's some MS Build logic in there. We get libraries for .NET 10, .NET 9, .NET 8, .NET Framework 4.6.2, and .NET Standard. So they actually multi-target for 5 targets. We have an icon, nice. And we have an analyzer. Now, fun fact, this analyzer is also multi-targeted, but when it comes to analyzers and source generators, you don't multi-target them by target framework like .NET 10, because it's not .NET 10 itself that is, it's not, when we target a library, that's then depending on what target we build, like let's build for .NET 10, this is this code is executed at one time. So when we then run this library, it's a one-time dependency. But when it comes to analyzers, those are build time dependencies. They don't run when the user's application run. They run when we build the project or when we load the project in Rider or in Visual Studio. So we're not targeting a target framework, but we're targeting a version of the compiler. So there can also be multi-targeting for this compiler version. And then in there, C#, this could also be Visual Basic. We essentially then have here a source generator for logging. But we can't look at it any further.
Exactly.
Kind of would
Wouldn't
be
it be
cool.
great?
Yes. It would be cool if we could inspect that little DLL and say, hey, this little generator actually includes, I mean, we could go to the source. Let's go to source.net.
Yes.
and find I think that's the logging generator. No, that's not this logging generator. I just want to jump to the source code. That's the source code of .NET. So we can go to libraries, find logging.abstractions. And here is the generator. Here's the source code of the generator. And yeah, but that's the source code. And I only found this because I knew where it is. If I don't know where the source code is, I really don't know what's in this package.
Exactly. And all I want for Christmas is to know what is inside and see which generators or analyzers or Roslyn components are there. I think, yeah, that would be really good for next year. And luckily,
oh yeah,
yes,
no, go
luckily
ahead.
we might look into this next year. We have a really really cool project planned. We're not gonna spoil it because it's a Christmas present. Yeah, so definitely subscribe to some of our channels because we're gonna go on our Christmas break now and we'll only be back next year. But yeah, with some really exciting,
we can have a lot of stuff. Well, I guess we will do even more Roslyn than we ever did.
I think so.
And we will build a browser application where you can load NuGet packages without loading them in your disk, and we can inspect them in the sandbox of the browser. We'll also build a desktop application where you can inspect your local projects and emit some additional, try to expose everything that Roslyn knows about your project, giving it more info. So we have browser applications, desktop applications. Maybe we go mobile, not sure. Since we're building applications, so far we only build tools and compiler plugins. We will also go a little bit into architecture to some degree.
Exactly.
Of course, we will need a lot of help from a lot of our friends. So we'll also have guests again. And then, yeah, maybe we'll have in a year for 2026 Christmas tree, we will put this tool that we will start using the proper name next year in as a gift, as a package. It will be wrapped as a NuGet package.
I love that. Yes, and so please, if you haven't already, like and subscribe so you don't miss out on any of our content. Also, if you have any questions or suggestions, we always love to hear from you. So definitely use any of your preferred channels. You see them on the screen now to reach out. I also want to say huge thank you to the organizer of C# Advent. Matt Groves, thank you so much for organizing this every single year. It's a real pleasure to be part of it, and it's so much fun discovering all of the different contributions in this Advent calendar. Huge thank you. And yeah, I also want to thank some very special people without who this we wouldn't do this probably because we've been at it for a couple of years, and we have we have I don't know, I think when we started out we were like, is anybody going to be interested in this, who's who are we going to reach? And we've actually reached quite a few followers on our streaming platforms. On YouTube, we've got how many was it? Just over 300, which seems insane to me. This is amazing. Every time I see it, I can't really believe it. But yes, and also obviously our loyal Twitch followers. Thank you so much to you. Thank you. Oh wow. let's go full meta here. Thank you so much to our regulars. Thank you so much to Eric, Toast in Training, Your Salty Devil. Also, Jason Bock and Stuart, who've not only helped us from the comments but also on stream. And yeah, you really make this stream super special for us. You teach us a lot, and you just really, I don't know, make our evenings. It's really true. Like it's yeah, it's wonderful having you, and you've many of you have been with us from the start, so that's, yeah, it feels like it's been quite the journey, and it wouldn't have been possible without you. Thank you, obviously, also to any streamers who see us for the first time. And yeah, happy holidays.
Yeah, let's forward Eric's message here. This has been amazing. Thank you very much for watching. Enjoy your holiday season. And as always, and it will be inevitable, we'll be back.